One example would be Sears. So Sears have been trying to solve their big data problem in different ways. As I said, as I've been saying, that big data is a problem statement and you can solve big data in different ways. What are the different ways? Well, Oracle has Exadata. Then there is something called Teradata, which is again a relational database, but on a huge scale. And then you have SAS, and then you also have IBM Netezza. There are so many different big database solutions available in the market. The biggest challenge is these all are hugely expensive machine, guys. A client who uses Teradata, their vendor locked into Teradata, and the expense is humongous. You cannot even think about the expense in that way. So Sears had the same problem. They found out that the cost of project was increasingly growing, and they did not find a lot of advantage by migrating from a relational world into Teradata or Oracle Exadata. So when they moved into Hadoop, they saw that the same performance or even better performance they were able to achieve in a fraction of a cost. So Sears case study showcases that compared to other big data solution, Hadoop is the way to go because Hadoop comes at a fraction of a cost. At the end of the story, guys, everybody talks about the return on investment. Everybody talks about the profitability, right? So Hadoop definitely is the way to go because it is easy to integrate and highly economical in certain ways. So this slide and the next slide, we're going to talk about and compare how things were in traditional world versus now. So let's say that imagine that I have huge amount of data. And imagine that I only have relational database. I have a traditional Oracle-based system. Let's see how I can use Oracle for solving a business decision-making problem, right? First thing is instrumentation of different ingestion platforms. All right, I find out that I have 4 different channels. So I collect my data. If I'm collecting 4 different variety of data, how am I going to fit this data into a single platform so that I can manage them together, right? So putting this into a single platform, a single table is a huge challenge. So challenge number 1, putting data from different sources. Second is, if the data is so huge, if the data is coming, in bulk, how much of effort you can give to put the data into a single table. You cannot have an Oracle table that is spun across in cluster. An Oracle table cannot be divided into multiple nodes, right? So a table has to reside on a single server. So second question is, how do you manage that large amount of data? Third question is, even if you have the data, how will you process it? If in an Oracle you have 4 terabytes, 5 terabytes of data, that too is a very big deal, guys, to load terabytes of data into Oracle. If you have terabytes of data into Oracle, how can you process the data? If you start processing the data into Oracle, it's going to take you days to process it. Third question is process capabilities of Oracle. And the fourth one is definitely after some months you're going to archive the data because you are limited by your size of the hardware. So if you are limiting your data, it's called premature death, you are going to archive the data. If you are archiving the data, you're killing the data. You cannot use the data later on for analytics or decision-making capabilities. So fourth question is, how do you avoid premature death of the data? So these all are the questions that you normally ask yourself if you go with the traditional approach of solving a big data problem, right? But now with a big data Hadoop-based solution, the answer is pretty simple. As I said, we'll talk about this later on, but as I said, Hadoop has at least 2 parts to it. One is the data storage part, second is the data processing part. So when I talk about Hadoop as a data storage part, you just think about dumping any amount of data in there. So first problem is solved, dump any amount of data from any source. Why any amount of data? Because Hadoop is linearly or horizontally scalable, right? We talked about it. If you have 10 nodes and you see that your 10 nodes are getting filled up, you add 10 more nodes and make it as 20 nodes, right? So you are not limited by the storage capabilities of Hadoop. So first question and second question are solved. Third question is, Hadoop also provides you with a data processing platform. It has a processing engine. Now with the processing engine, you can divide and conquer. You can process large amount of data in a fraction of a time. So the third question is also solved, which is processing of the data in a limited time. And the fourth one is, because now you are not limited to the storage of the data or processing of the data, there is no need of archiving the data. So you don't even archive the data. So you just say, hey, no need of archiving. So there is no premature death of the data. So by introducing Hadoop as your layer, you can solve all the basic 4 problems: storage, variety, processing, and archiving. All these 4 questions will be solved by introducing Hadoop instead of a traditional system of solving this kind of a big data problem. What about the data which has been processed daily? Stocks. Does big data respond to certain calculations in fractions? See, big data and Hadoop is evolving. Big data does provide real-time analytics also. Again, I'm just quoting myself, guys. Big data provides real-time processing also. Unfortunately, Hadoop as of now doesn't support it. There are other technologies under big data umbrella, but which is not under Hadoop. So Hadoop is still batch mode, but there are certain real-time analytics engine also. Having said that, people can have minute by minute, real-time reports, hourly report, 15 minutes report, so you can have any amount of report you want. So for the stock exchange, normally they have pretty 10-second reports, right? So you can have reports generated every 10 seconds. That's also possible. So there is no limitation. As I said, guys, velocity is one of the use cases, right? This NCDC or stock exchange rates and changes. This is a classical example of a velocity of the data. Can you use Hadoop for ETL data mining? Yes, yes. See, the question cannot be data mining, because data mining cannot be your end goal for any Hadoop-based systems. What you need is, some kind of analytics which can be the end result. Your end result will be some kind of reports. Using the report, you can do a number of things, but your end result will be a report of certain things. Report might not be a normal report. It can be just a tabular report or an analyzed data, something like that. So if you have the end result as your report, a lot of time you're pushing the data from variety of different sources, right? You're moving the data from different sources. So what you do is, you have to perform some kind of operations on different sources of data so that the data becomes comparable to one another. And that is where you talk about as ETL. ETL stands for extraction, transformation, and loading. If your data is coming from 5 different sources, then you have to run ETL logic on each of the 5 sources so that all of the 5 sources get converted into a common platform or a common template on top of which you can run an analytical algorithms. So ETL is definitely a subsection inside your big data solution. What are the name of reporting tools available for big data? Well, there are so many, there are so many. Tableau, Talent, Pentaho, Informatica BDE, Elasticsearch. There are so many different reporting tools available. Vamsi says, which platform is big data provides the real-time reports? Which platform in big data? I'm not sure about the question. Well, not talk about the real-time reports. We're talking about real-time analytics. Well, reporting is not a part of big data, right? I mean, it is not a part of Hadoop, right? Hadoop does analytics for you. After Hadoop, after you have analyzed the data, you can plug in your BI tools. So BI tools will be part of big data, but not part of Hadoop, right? So Hadoop only provides the analytical layer. After you create analytical data, that data can be pushed to your BI reports to create wonderful matrices and charts. So if you're asking which tool provides real-time analytics, answer would be Storm and Spark and all these things available, right? So these are solutions that provide real-time analytics. They run on top of Hadoop though. That data archiving is storing of the data, right? Yes. Is Hadoop the only technology supports big data? No, that's what you said, right? A couple of slides back. You have Teradata, Exadata, Netezza, SAS. These are all big data solutions, out of which Hadoop is the major player because it is open source and it is economically very viable. Oracle RSC is also scalable. Can that be used for storing big data? Well, Oracle RSC is scalable, yes, but the biggest challenge with Oracle is one table cannot scale up. You can have multiple tables in multiple nodes in a clustered environment, but you cannot have, let's say, employee table. You cannot have employee table divided into multiple nodes. No, Oracle doesn't provide that kind of scalability yet. It cannot provide ever though. So Oracle systems, even though you can have 3-node Oracle system, but the tables will still be residing on one node. You cannot have one table split across multiple nodes. Partitioning is not available in Oracle or any other traditional systems as of now. So as Hadoop is, so how is data kept alive without storing data? No, storing the data means keeping the data alive, right? So when the data is available in Hadoop, the data is alive for processing, right? We are not storing or dumping the data into a, let's say, we are not throwing away the data into a, the tapes, right? So once you store the data into tapes, there is no way you can write processing of the data. In banking, if I store archive data into Hadoop, is it possible to do a search on the data? Yes, absolutely, yes. Hadoop does provide search engines on top of that, yes. If your data doubles up, then ideally you double up the nodes again after a period of time. What is RDBMS doing in this diagram? Well, RDBMS has a lot of things to offer, right? Because a lot of time, what you can do is you can push your analytical results into a relational RDBMS table. And using the table, that table can be the backend of your UI. So Amazon UI. The UI can only be loading the data from RDBMS, whereas RDBMS has been populated by your Hadoop analytics system. A lot of things is, a lot of use cases can be where your UI layer, like your, Amazon or any other, let's say Best Buy, their system, their portal connects to a relational database, whereas the relational database is being populated from your Hadoop layer. For real-time analytics, data should be pushed to Hadoop. Is it possible? Yeah, why not? Yes. Can conventional ETL tools like Informatica or DataStage use Hadoop as a data source? No. Everybody is moving into Hadoop. So Informatica has bought out their own version, which is called Informatica BDE. BDE stands for Big Data Enterprise, right? So every different tool have moved into Hadoop. So traditional systems, conventional ETL tools, they are trying to bring the big data flavor to their own tools. But again, guys, it is a double-edged sword. So if you learn Hadoop, Hadoop comes with its own services where you can write custom code for ETL processing. But again, a lot of people do not want to write codes. They'll still fall back into all those tools like Informatica and DataStage. So there are a lot of players like Informatica. They have been trying to bring a big data flavor to their own tools, and they are doing it for now. So Informatica BD edition came into the market, right? So everybody is trying to be in that zone where they can still work with big data. Sankirtan says, why there is no data archiving? Well, there is no data archiving because Hadoop itself, see, why do you archive data? You archive data because you are limited by the storage platform. You archive the data because you no longer can save the data into the main database. You want the data to be residing on another archived database. With Hadoop, you are not limited by the storage capabilities, right? You do not need another database to support it because Hadoop is unlimited. It is unlimited. You can just think about that unending limit of the data. So you do not need it in that way. Storage and processing is good. Would it replace the databases as we know today? Big data and traditional databases, they serve and they cater to different market segments. We have a slide. We're going to talk about this slide in details, but you use really, as I said, right? So every use case cannot be termed as a big data use case. So for a big data use case, you are not supposed to use Oracle or relational databases. For relational use cases, you're not supposed to use big data use cases, right? So if your use case allows you to use big data, then yes. If not, no. Traditional systems would work much better. In PPT, there is no data archiving. What does it mean? It means if your data is in Hadoop, you do not have to archive the data into tapes, right? You do not want to throw away the data. You can keep the data into your Hadoop system for as long as you want. No necessity of dimensional modeling or SCDs in Hadoop. Let's not go into these, guys. We're jumping the gun now. SCDs and all these are specialized cases of Hadoop. Can you do an SCD in Hadoop? Yes. How to do SCDs in Hadoop? Well, that's a far-fetched game, guys. Normally, Hadoop doesn't support SCDs directly out of the box because it is an analytical system, but you can still have a lot of design patterns where you can implement SCD1 and SCD2. So yes, you can do that, but we'll not cover this up here. As shown in the diagram, how data is located in RDBMS from Hadoop. What is the technology? Well, there are different technologies. We're going to talk about it. One of them is called Scoop, where you can load the data from a Hadoop platform into RDBMS. You can export your data into an RDBMS from Hadoop data. That's called that tool is called Scoop. We're going to talk about this, and we're going to learn Scoop also in our 30 hours. It says if no archive, how does it affect the data retrieval? Well, no, right? So that's what I'm saying. You think about archiving because, see, why do you archive? Because you're moving the data from your main database into an archive because your main database will have limitations storing large amount of data. But if my Hadoop has no limitations on storing the data, if I'm not limited to storing the data, guys, then why should I archive the data, right? I have no requirement of archiving the data because Hadoop can grow as much as you want. If you say that, will that be a problem for me while retrieving the data? Well, no, because when you are adding, if you have a 10 node machine, if tomorrow you go and increase it to 20 node machine, you're not only increasing your hard disk, you're also increasing your processing powers, right? So you're increasing exponentially your processing capabilities. So there is no way you're limiting yourself. right? It will not become slower. In fact, it will become better. More number of nodes becomes better for you because you're also adding up more CPUs and RAMs to your system. Visualization tools for big data and analytics, would you please state them again? Yeah, one of them is Tableau, Talent, Pentaho, Informatica, and Elasticsearch. That's what I can think about right now. Never seen a storage other than table columns. Eager to see how it is stored on Hadoop without tables. See, Hadoop doesn't solve anything that has never been solved before. So do not think about Hadoop as a mystery or a technology that has never, that has been trying to do something that has never been attempted before. No, Hadoop is not even a technology, guys. Only thing is, everything that you can do on a smaller scale, now you can do on a larger scale because of Hadoop. That's the only difference. All right. So it is not that Hadoop can do something that has never been done before in the world. No, Hadoop doesn't do anything out of the box that has never been done before. Hadoop cannot do anything that has never been done before. Only thing is, if today you are limited by the processing and the storage capabilities, then Hadoop is for you. It cannot be that, that you're, let's say, using Python. Using Python, I cannot solve this problem, but with Hadoop, I can solve the problem. No. Hadoop cannot solve a problem that has never been solved before. Hadoop can only solve those problems which cannot be attempted or any other technology because of limitations in hardware. Yeah. So we cannot say that Hadoop is something new which has, which has come up or brought something new to the industry. No. Hadoop is the same old thing, but now we are not limited by hardwares. So it is a data-driven policy, guys. It is not a technology-driven policy, right? So we are not learning a new technology per se. We will not learn a new technology here. We're going to learn different ways of managing data here, right? But during managing of the data, we'll see some services where we might have to learn something new, unlearn something old, and relearn something new again. All right. So it's an interesting phase of next 30 hours. In fact, maybe next 28 hours, where we're going to explore the world of Hadoop. But we'll see that Hadoop is not a technology which is bringing you algorithms which is trying to solve something. Hadoop has nothing to do with technology. Hadoop has everything to do with architecture that allows you to solve problems which are limited in today's world because of the hardware capabilities. Do you use any tool to load live data into Hadoop? Yes, well, again, as I said, Hadoop doesn't come with certain things, but if you are, guys, people who are from, web background, they can relate to this. So there are two ways of loading data into any system, guys. Any system, forget Hadoop, any system, there are two ways of loading data. One is a push model, another is a pull model, right? And Hadoop supports both. In certain ways, you can push the data. What is a push technology? A push technology can be a socket-based program. A push technology, maybe, a web service where somebody is, creating a connection and loading and pushing the data into a system. That's the push technology. And there is a pull technology. Pull technology means you pull the data from a source. For example, I can have a system. I can write a small application that goes into Twitter and fetches certain feeds from Twitter based on a particular hashtag. That's a push-based mechanism, right? So to load live data into Hadoop system, you have to identify those channels and write the code accordingly. Those code will not be Hadoop code. They will be pretty much normal code where you pull some data or you push some data, right? So supposedly you are talking about customer-centric data, then you have to push the data into Hadoop. But if there are certain APIs available, like let's say Twitter data or some public data, then you can pull the data from the internet also, right? So it is possible in certain ways. In Hadoop, is Hadoop available for free to install? Can I install it on my machine? Can it use my machine database to scale and check it? Hadoop cannot be installed in a single machine because it is a distributed software, firstly. But to test out Hadoop, to work with Hadoop and to learn Hadoop, Hadoop comes with a version, it comes with a phase which is called a pseudo-distributed mode. A pseudo-distributed mode is the one on which you set up Hadoop locally in your machine in a VM and you can run some algorithms in there, but it will not be a productionized version of Hadoop. You cannot work with large amount of data. You cannot scale it up like that way you talk about, right? So normally Hadoop is actually, distributed model. You work on a set of nodes in cloud or in premise center, but only for testing. Yes, Hadoop comes with a pseudo mode also. For these examples and practicals, I'll be using Puri, guys. I'll be using Puri because VM is very slow. I'll be using Puri, and I have a Puri set up for Eduvega trainers. So using the Puri, I'm going to show you an example of a small 3-node cluster. And then, if time permits, I'll also show you a couple of examples of a productionized version of Hadoop, for some of the clients that I work with, some of the dev environment of Hadoop, where people have actually installed Hadoop and worked on top of that. All right, guys. So what is Hadoop? We said that Hadoop is a solution to what big data is a problem. If big data is a problem statement, then Hadoop is a solution. Hadoop is one of the ways of solving big database solutions. Other ways are, of course, Netezza and Teradata and all these things we talked about. Now, what is so special about big data? What is so special about Hadoop? So we have talked about, a lot of us know about grid computing. Question is, how is Hadoop different from grid computing? In grid computing, also have a lot of machines working together, interconnected, and handling a request. How is Hadoop different from grid computing? The answer lies in the internal processing, internal structure of how the data is stored. Now, let's talk about the internal data storage platform of Hadoop, which is called HDFS. HDFS stands for Hadoop Distributed File System. How is this file system different? What are the file system that provides advantage, and how this HDFS differentiates Hadoop from a grid computing? That's what we're going to talk about right now. Now, every machine has a file system, right? Windows will have NTFS file system. Mac will have, Mac 13 file system. Unix will have, or Linux will have POXIS file system. Debian will have its own file system. So every single operating system will have its own file system, right? And every single file system provides you with a platform for storing the data. For example, if you have a Windows machine, then in that machine, in the C drive, you can dump any data that you want, right? And that becomes a file system. The file system manages those files. Similarly, Hadoop comes with a file system, and that is called HDFS file system. Now imagine that I have 10 nodes, right? If I have 10 nodes, and if I have installed Hadoop on these 10 nodes, then in all the 10 nodes, there will be a file system that gets installed on top of the native OS. You still have native OS. On top of the native OS, you have a file system that gets installed, and that file system is called HDFS file system. When you install HDFS file system, the advantage is, if you log into any of the machine, you log into machine 1, you log into machine 10, you log into machine 5, no matter which machine you log into. When you log into the machine and when you look into the Hadoop system, you will not see that there are 10 different machines. For you, you feel and you see as if there is one single huge big machine. So HDFS file system is a distributed file system. When you log into any machine that has installed the Hadoop system, then you find yourself as if you have logged into a huge machine. You forget about the machine boundaries. The advantage is, if I have, let's say, 10 different machines, each machine having 1 terabyte. I'm having 10 machines, each machine having 1 terabyte, guys. Imagine that these are normal machines. Can you save a 2 terabyte file in these machines? Can you do that, guys? Imagine there is no Hadoop. Can you save 2 terabyte file into 10 nodes where each node is a 1 terabyte hard disk? Can you save 2 terabyte file in a 2 terabyte one single file into this 10 machines? No, right? You cannot do that. You cannot save one single file which is 2 terabytes big into any of the machines, because the machines are limited by their hardware capabilities. Even though there are 10 machines in a single network, but each one of them is limited by their own OS. But now with HDFS, because HDFS is a distributed file system that runs on top of the machine, you log into any machine, you dump 10 terabyte file also. These files will be internally splitted across and saved into each of the nodes. So you do not have to worry about the block. You have to not worry about the size boundary now. You are not limited by any boundaries. You log into any machine, you feel as if you have logged into one single huge big machine. And that is the advantage of HDFS. Now let's look into the advantages. So if I have one single machine, and imagine that I take let's say 60 minutes for processing 1 GB of data. How long do you think will take for processing same 1 GB data into these 10 machines now? 6 minutes, right? Perfect. So you get the idea, right? So if one machine can work 60 minutes to process 1 GB of data, 10 machines together will process the same thing in 6 minutes. So I'm getting 1/10 of the performance, right? I'm getting 10 times the performance in this case. And that's the advantage of a distributed file system, because I'm processing things in parallel now. What if the size exceeds 10 terabyte? If the size exceeds 10 terabyte, it means you have to add a couple of more machines to the cluster.